Welcome to this video module on the Dresden switchyards. In this module, we're going to cover the introduction and Objective 1. For this video series, you want to make sure you're looking at lesson plan DRE 262 Lima November 003. Before we get started, let's take a 2-minute drill, validate that we're ready for training. Please make sure that your cell phones are in off. Validate that you have the correct lesson plan. Again, the lesson plan is DRE 262 Lima November 003. Please be attentive throughout this video presentation. Take breaks as needed. As always, provide feedback to the training staff. Our objective for this module is to discuss the purpose of the Dresden switchyards and the conditions under which they are designed to function. We need to ask ourselves the question, what is a switchyard? A switchyard is an electrical circuit that receives power from a source and directs power to a load. A switchyard forms three purposes. The first purpose is to provide a conduit for electrical energy transfer. In other words, a piece of metal that's going to transfer voltage and current from the generating source, which in our case is the turbine generator, to electrical load for sale, the transmission substation. The switchyard also provides protective relaying for emergency situations. Finally, the switchyard provides isolation equipment to allow for maintenance. It's important to note that while this does cover Objective 1, more detail will be provided on these particular purposes in future objectives. The Dresden switchyard has three different voltages. Switchyards are typically classified by the operating voltage. At Dresden Station, we have a 345 kV switchyard, 138 kV switchyard, and a 34.5 kV switchyard, which is usually shortened down to 34 kV. kV in this situation stands for kilovolts. So what we're really talking about, for example, in our 345 kV switchyard, is that the voltage for transmission is 345,000 volts. Let's start by talking about the 345 kV switchyard. The purpose of the 345 kV switchyard is to receive 345 kV inputs from main power transformers 2 and 3. The switchyard provides connections for supplying off-site power. In other words, we're going to sell our power to ComEd. We do this by using the transmission system to transfer this 345 kV power to a local substation for sale at your home or office space. An important feature about the switchyard is that it provides off-site power back to the station via the reserve aux transformer. In a different presentation known as aux power, you'll understand how this is accomplished. But for our purposes today, what you need to know is that transformer 32 is directly fed from the 345 kV red bus, and transformer 22 is fed from transformer 86, which is its normal feed. A relay house is provided which contains support and protective equipment. The 345 kV switchyard is arranged in a double ring bus. The blue bus is fed from unit 2. And an easy way to remember this is that 2 is on blue. The blue bus is the northernmost bus in the switchyard. The red bus is fed from unit 3. The red bus is the southernmost bus. The 345 kV buses can be connected via 345 kV bus tie 4/8 circuit breaker. In a future objective, we will look at the double bus arrangement, and I will show you what the blue bus and red bus are. It's also important to note that when talking about the switchyards, we must use proper nomenclature. We don't say bus tie 4/8 circuit breaker. We say 345 kV bus tie 4/8 circuit breaker. The 138 kV switchyard provides lower voltage power for transmission. The 138 kV switchyard is different from the 345 kV switchyard in that it's not a double ring bus. It's a straight line system that's broken up into 4 buses. The 4 buses are connected together with a breaker that's open between them. The 138 kV bus 1 and 2 are tied together, and that forms the east side of the 138 kV switchyard. The 138 kV bus 3 and 4 buses are tied together, which forms the west side of the switchyard. 138 kV bus tie 2-3 circuit breaker is normally open. And again, we'll see this in future objectives. The 138 kV switchyard is fed directly from 345 kV yards via transformer 81 and transformer 83. There's a really good thumb rule that you can remember or use to determine which transformer feeds which bus. It's the thumb rule of 5. If you take the last number of the transformer and add it to the bus number that the transformer is connected to, you'll get the answer of 5. So for example, transformer 81 is the feed for 138 kV bus 4. Bus 4 plus the 1 from transformer 81 equals 5. That's how you remember it. 83, in other words, transformer 83, would be the direct feed for 138 kV bus 2. 3 plus 2 is 5. The 138 kV switchyard provides input into Unit 1 via transformer 12. 138 kV switchyard also provides a backup 138 kV power supply for transformer 22. Finally, the 138 kV switchyard feeds the 34 kV switchyard via transformer 10. Our 34 kV switchyard provides a connection point between the generating station and the transmission substations. In short, we power local areas. It's fed from 138 kV switchyard via transformer 10. It also feeds transformers 13 via line 7281 or line 1266. The 34 kV switchyard feeds various plant loads. These include the flow regulating station, the lift station, and some outbuildings. For example, the training building. Our objective for this module was to discuss the purpose of the switchyards and the conditions under which it is designed to function. It's important to note that the switchyards are designed to operate under all conditions. In other words, it's designed to operate 365 days a year, 24 hours a day, 7 days a week. For the best understanding of the switchyard system, it is suggested that you view the video covering Objective 4 next.